Okay, so example 12, f of x equals the natural log of 2x squared plus 1. So for this one, so we have natural log of blah. So then we know f prime of x is going to equal to 1 over the blah, so 1 over 2x squared plus 1, times the derivative of the blah, so times the derivative of 2x squared plus 1, which in this case is 4x. And so cleaning it up, we end up with 4x over 2x squared plus 1 for our derivative of this function. Alright, example 13. So h of x equals 3x times natural log of x. So basic product rule here. So h prime of x is the first function, so 3x, times the derivative of natural log x, which is 1 over x, plus the second function, natural log x, times the derivative of 3x, which is 3. So cleaning this up, we end up with 3 plus 3 natural log x. You could pull a 3 out of this and write this as 3 times 1 plus natural log x. That's not really going to make it any prettier or anything, so I wouldn't worry too much about that. I would just leave it as this. So h of x equals 3 plus 3 natural log x in this case. I would not worry about that other simplification. But if you do, that's okay. It's just going to not help you too much later on. Alright, so 14. F of x equals natural log of 2x over x plus 3. If you can use your natural log properties from algebra to simplify first, it is always going to make your life easier. Because looking at this right now, if you try to just attack this with brute force from the beginning, what's going to happen? You're going to end up having to do 1 over a fraction times the derivative of a quotient. So having to use the quotient rule in there. And that's going to just be ugly algebra. Now, I'm not saying you can't do it that way, but you're going to be more likely to make a mistake if you do it that way. Instead, let's rewrite our function first. We've done that in the past, and it's made things easier. It's going to make things easier in this case as well. So if we rewrite this, we can rewrite this as, so remember the quotient of inside of a logarithm, you can rewrite as the difference of two logs. So we can write this as natural log of 2x minus natural log of x plus 3, which right away is going to be easier to work with. But then we can break it up even more. So we have a product inside of a logarithm with the natural log 2x. So we can rewrite this as natural log of 2 plus natural log of x minus natural log of x plus 3. Now this is going to be a lot easier to differentiate. So f prime of x now, we can do it term-wise. So the derivative of f of x is equal to the derivative of each of these pieces. So the derivative of natural log 2, well remember, natural log of a number is a number, right? So that's just a constant. So the derivative of natural log 2 is 0. The derivative of natural log x is just 1 over x, minus the derivative of natural log of x plus 3. So that's 1 over x plus 3 times the derivative of x plus 3, because we're using the chain rule there, because it's natural log of blah. So times 1. And then cleaning this up, so f prime of x is 1 over x minus 1 over x plus 3. Now we want to get a common denominator here, which is going to be x times x plus 3. So this is going to be x plus 3 minus x over x times x plus 3, which then just gives us 3 over x times x plus 3 for our final derivative. Now, when you're simplifying these, you always want to get them over a common denominator. It's going to make what we do in the next chapter easier. So you always need to rewrite it over a common denominator. Okay, example 15, very similar to the one we just did. So, same idea. So, natural log of the cube root of x minus 1 over x plus 1. We want to go ahead and rewrite this using our properties. So remember, cube root's the same thing as saying natural log, in this case, of x minus 1 over x plus 1 all to the 1/3 power. So we can use that property to pull out our 1/3. So 1/3 natural log of x minus 1 over x plus 1. And now rewrite that as a difference. So 1/3 natural log of x minus 1 minus 1/3, because we have to distribute that 1/3 to both of them because the 1/3 is multiplied by the entire natural log. So minus 1/3 natural log of x plus 1. And so now we can differentiate this fairly easily. So y prime then, 1/3 times the derivative of natural log x minus 1. So 1 over x minus 1 times 1, because that's the derivative of x minus 1. So using the chain rule there, right? Minus 1/3 derivative of natural log of x plus 1, 1 over x plus 1 times the derivative of x plus 1, which is 1. Now be careful. It's easy to assume the derivative of the inside is always 1 on these. It's not. So then we end up with 1 over 3 times x minus 1 minus 1 over 3 times x plus 1. So to get a common denominator, we want to make this have a denominator of 3 times x minus 1 times x plus 1. So multiply the first one by x plus 1 over x plus 1. So we have x plus 1 minus x minus 1 all over 3 times x minus 1 x plus 1. And so y prime then, cleaning that up, we end up with 2 over 3 times x plus 1 x minus 1. And we're done. All right, so the next one, y equals natural log square root of sine x. So same idea, we want to rewrite this using our power rule. So we can rewrite this. Remember, square root is the same thing as saying the sine x to the 1/2 power. So this is 1/2 natural log of sine x. So now then, y prime is going to be 1/2 times the derivative of natural log sine x. So that's 1 over sine x, since it's natural log of blah. So 1 over the blah times the derivative of the blah. Derivative of sine x, which is our blah, is cosine x. And so we're left with cosine x over 2 sine x, which we can then rewrite as 1/2 cotangent x. And we're done. All right, so one last example. So y is equal to log base 4 of 5x plus 1. So same idea as what we've done in the past. The only difference now is we don't have our logarithm being a natural log. So we just use the other rule. So y prime then is 1 over natural log of the base. So 1 over natural log 4. And then times, the rest of it's the same as if this was natural log. So 1 over blah, so 1 over 5x plus 1, times our derivative of the 5x plus 1, which is just 5. And so we're left with 5 over natural log of 4 times 5x plus 1. And that is our derivative.